There are opportunities to explore computational thinking in many of the experiences our children have in their early years settings. From creating story maps, sorting objects, playing with words to make sounds, these activities all have elements of or opportunities to explore computational thinking. To help you learn more about computational thinking, this video shares two resources which we've adapted from Barefoot Computing Science, linked to Curriculum for Excellence Early Years Experiences and Outcomes. The first is an introduction document which explains a little more about computational thinking and maps computational thinking skills to Curriculum for Excellence. There is also a part which explains how the remaining activities in this course are mapped to Curriculum for Excellence. We have created activities for you to use in your classroom that show you what computational thinking looks like in early years. These include a wide assortment of familiar activities such as water play, outdoor play, role play ideas, games and challenges. Each resource has a description, key questions and assessment support. Once you've tried these, you might see how your planning already has computational thinking in it, and then you can just highlight the computational thinking that you already do. Each activity is mapped to experiences and outcomes for planning and the benchmarks for assessment. Across this development, there is a clear progression of skills, and this progression is likely to go beyond the minimum expectations of CFE. We have reviewed the experiences and outcomes for computing science and believe there is capacity for learners at all stages to undertake concepts at higher levels. Let's talk a little more about sorting, ordering and sequencing, grouping and naming, and abstraction. Often in school, we use the word sort when we ask learners to spot what is the same about a set of items. For example, we use sorting hoops or sorting trays for children to group items by colour, shape, size, use, etc. When we use the term sort in this way, it's a little different from how computing scientists would use the term. In computing science, sorting means putting things into order, rather than grouping things. In mathematics, there's a similar distinction. These maths outcomes deal with sorting and grouping objects, which is a great computational thinking skill. So, if we sort the set of numbers 5, 2, 3, 1, we might put them in order, from smallest to largest, resulting in 1, 2, 3, 5. We might call this ordering. Computing scientists would say they sorted the numbers. The term sequencing is also used to mean putting in some kind of order, such as sequencing a daily routine. In computing science, we are often concerned with spotting common features of a set of items and naming that group. Computing scientists use the term class for the name of a group, and the term generalization to describe the activity of working out a general group. For example, I have a pet called Lola, and my friend has a pet called Diggles. Both of these pets have whiskers, sharp claws, and chase mice. One of them has long fur, the other short, but they are both cats. Here we have two pets with similarities and differences, but they both belong to a general group, a class called cats. Abstraction is another great computational thinking skill. Abstraction is working at the right level of detail for a task. We abstract as we summarize, as we ignore detail we don't need at that point in time. We abstract when we make a mind map. Decomposition is a type of abstraction and is often used to describe how we break something down into parts. Usually in computing science, we break problems into smaller and smaller parts to make them easier to solve. This overview document contains a table of experiences and outcomes from across the early years curriculum, cross-referenced with our computational thinking skills. We hope it demonstrates some of the opportunities to engage in computing science thinking, with activities that you're already leading with early level learners. The second document is a set of prompt cards, which highlight opportunities to engage learners in computational thinking. These cards can be printed, laminated, and available in class to provide questions and prompts to use when discussing learning activities with children. For example, when looking at pattern, you could ask, are these objects the same? Or for tinkering, I wonder what might happen if. These little prompts help us all to focus on computational thinking as a tool to understand our world. So, you're now at the end of this video. Answer the questions and don't forget to submit your answers to complete this activity in our course.